What is the derivative of e to the x and how can we prove it? For those that don't already know, the derivative of e to the x is itself e to the x, completely unchanged. So let's prove this fact via first principles. In case you're unaware, and if so, it's back to basics for you, the general definition and formula of the derivative is if given f of x, its derivative f prime of x is the limit when h approaches 0 of f of x plus h minus f of x all over h. This is how we prove by first principles. For this question, we'll also need the limit definition of Euler's number, that being the limit as n approaches infinity of 1 plus 1 over n all to the power of n. Keep this in mind because we're going to be using this later. So with our initial function f of x equals e to the x, let's find its derivative f prime of x and go through the steps one at a time. First, we apply the definition of the derivative, thus f prime of x equals the limit as h approaches 0 of e to the x plus h minus e to the x all over h. This is our f of x plus h and f of x. Next, using laws of indices, we can rewrite e to the x plus h as e to the x multiplied by e to the h. If you're unclear of this step, then you might want to watch a separate video explaining it. I'll link it in the description. After that, we factor out the common terms, that being e to the x. This leaves us with e to the x multiplied by e to the h minus 1 all over h. Finally, we can use a property of limits and bring e to the x outside the limit itself. This is because the limit's variable is h and not x, meaning e to the x will not be affected and is thus irrelevant. We're left with e to the x multiplied by the limit as h approaches 0 of e to the h minus 1 all over h. Now let's look at the numerator on top first. We're going to be making a quick substitution. Let u equal e to the h minus 1. Later on, we'd like to change the limits variable from h to u, so let's test out the relation. When h approaches 0, u equals e to the 0 minus 1, which is equal to 1 minus 1, which is equal to e to the I pi plus 1. I'm kidding, u is equal to 0. Thus, we can swap the limits because as h approaches 0, u also approaches 0. Back to the substitution itself, u equals e to the h minus 1. Rearranging to find h, e to the h equals 1 plus u, and so h equals the natural log of 1 plus u. If you don't know how we got here, break up with calculus, algebra is calling. So let's plug these new values back into our equation. Initially, we had f prime of x equals to e to the x multiplied by the limit as h approaches 0 of e to the h minus 1 all over h. Now, with substitution, we get e to the x multiplied by the limit as u approaches 0 of u over natural log of 1 plus u. Multiplying both numerator and denominator by 1 over u, we get 1 over 1 over u times natural log of 1 plus u, and using the laws of logarithms, we bring 1 over u up as the power of 1 plus u, leaving us with 1 over natural log of 1 plus u to the power of 1 over u. It'll be clear in a second why we perform this in between step. Looking at the denominator applied with the limit, we're evaluating the limit as u approaches 0 of the natural log of 1 plus u to the power of 1 over u. Here, we're actually going to change the value the limit is approaching from 0 to infinity. As we can see, when u equals to 0, we have an undefined term from the 1 over u. We can replace 0 with infinity and vice versa, so long as we change the u terms, specifically by taking their reciprocals. Because the reciprocal of 0 is infinity / undefined, assuming we're taking absolute values for any smart people wondering about negative infinity. Changing the limit, u becomes 1 over u and 1 over u becomes u. One last step. We can use another property of limits. We bring the limit into the continuous function, natural log, to match our needs. For those observant people, and for those of you who possess at least one eye, you'll notice that the limits function now resembles the definition of e. So we can conclude that the natural log of the limit as u approaches infinity of 1 plus 1 over u to the power of u is actually equal to the natural log of just e. And the natural log of e is simply 1. Going back to our equation, we can evaluate that the limit is equal to 1 over the natural log of e, or 1. Therefore, f prime of x is equal to e to the x multiplied by 1 over 1, leaving us with f prime of x is equal to e to the x. So that's how we prove that the derivative of e to the x is in fact itself. If you have any other ideas for me to ignore, make a video on, do leave a comment.